In this example, we will solve the equation p equals 3 divided by the quantity 4 root t for the variable t. As a starting point, I begin my solving by getting rid of the fractions, especially since the variable we are solving for is in the denominator. To cancel out this denominator, I will multiply both sides of the equation by 4 root t. In doing so, the denominator and the new 4 root t on the right side of the equation cancel, leaving us just with 3 on the right side of the equation. Over on the left side of the equation, I will rewrite this as 4p root t. To solve 4p root t equals 3, we still need to isolate that radical. But again, we needed to isolate the radical when it was not in the denominator. So the next step in isolating that radical will be to divide both sides of the equation by 4p. By dividing both sides by 4p, we will be left with the equation root t equals 3 over the quantity, 4p. At this point, we have isolated the radical term. Now what we need to do is remove the radical by using the opposite operation. Since we are dealing with a square root, we will use the operation of squaring. Squaring a square root will cancel out the square root. But if we square the left side of the equation, we must also square the right side. When we square the right side of the equation, it is important to square everything on the right side, so we want to put that whole fraction of 3 over 4p in a single set of parentheses. Now on the left side of the equation, root t squared will simply cancel to leave us with t. On the right side of the equation, we need to remember that squaring a fraction means we're both squaring both the numerator and denominator of the fraction, and given that we have 4 times p in the denominator, both the 4 and the p individually have to get squared. So we're going to end up with 3 squared over 4 squared times p squared. And if we go ahead and simplify that a little bit more, 3 squared is 9, 4 squared is 16. And so this leaves us with 9 over 16p squared. So solving the equation p equals 3 over 4 root t for t transforms into t equals 9 over 16p squared. Again, we do want to make a quick note at the end of this work. What values of t and p make sense for any of these equations? From the beginning, we could not use a negative number for t, because if we had put a negative value in for t, we would have ended up with 3 over 4 times the square root of a negative number, and we cannot take square roots of negative numbers when we're working exclusively with real numbers. Additionally, because t is in the denominator, and putting a 0 in for t is fine with the square root, but turns that whole denominator into 0, we can not only not use a negative number, but t also cannot be 0 itself. So from the beginning, the t values we have to work with would be positive. And by forcing the t values to be positive because of the square root, we would have 3 divided by 4 times a positive number. The p values themselves also have to be positive. When we transform that equation into this t equals 9 over 16p squared, we have the same concern at the end. The original restrictions on the t and p values from the original equation have to still be carried down to the final equation.